Welcome to a new series, By a Few Degrees, where direction, not chance, writes history. Only on your dose of wowness.
66 million years ago, a rock the width of Paris was falling toward Earth at 45,000 miles an hour. The fate of every dinosaur, every surviving mammal, and the world you are sitting in right now came down to one number nobody could see coming. While the asteroid's size and speed were catastrophic, the specific angle of impact determined who survived. Today, we're going to show you that number, why it was the worst possible trajectory, and the version of this story where humans never existed. If you're new here, welcome to your dose of wowness. We're one episode into a brand new 10-part arc called By a Few Degrees, and this is the one that sets up everything that follows. Hit subscribe now so you don't lose the thread. It's going to matter later. Our existence was never a certainty. It is the result of a single mathematical variable, decided in the seconds before the sky actually fell. 66 million years ago, Earth was not a fragile world. It was a stable 180 million year experiment in reptilian dominance that had already weathered tens of millions of years of climate swings and volcanic episodes without losing its basic cast of characters. Mammals lived alongside the dinosaurs for this entire span, but they existed like mice in a world of elephants, resourceful, numerous, and entirely peripheral to the planet's governing story. In 2020, a research team at Imperial College London used three-dimensional numerical simulations to reconstruct the impact. By calibrating their models against the crater's actual subsurface structure, they were able to reverse engineer the asteroid's final trajectory. Their conclusion was specific. The asteroid struck at an angle of approximately 60 degrees. This 60-degree trajectory is the statistically worst-case scenario. It is the specific angle that maximizes the amount of vaporized rock high enough to circle the globe and stay there. The lethality of the 60-degree angle was amplified by the target. Hit the Yucatan Peninsula, a region with a very specific geological composition. Platform was rich in sulfur-bearing anhydrite and carbonate rock. Only a small fraction of the Earth's surface contains this specific chemistry. A vertical impact drives energy deep, while a shallow strike skips along the surface. But a 60-degree angle excavates a wide crater while simultaneously launching an enormous plume straight up, injecting hundreds of billions of tons of sulfur into the stratosphere. Once in the upper atmosphere, these compounds formed reflective aerosols that spread globally within weeks. They created a shield that blocked the sun's heat and light. The result was a multi-year impact winter, as photosynthesis-based food chains collapsed, from starving any animal too large to find shelter or a flexible source of calories. This dark layer of ash, known as the KPG boundary, marks the moment 75% of all species on Earth disappeared from the fossil record. The combination of 60-degree geometry and sulfur-rich geology created the most efficient extinction delivery mechanism possible. Before we get into what almost happened instead, if you want to know the second this arc's next episode drops, turn on notifications. We're about to zoom out from 66 million years ago to 4.5 billion, and it's an even stranger story than this one. To understand how close the dinosaurs came to surviving, we can look at the simulations for alternate impact geometries. In an 85-degree simulation, energy is driven deep into the crust, preventing a global winter. A shallow 20-degree impact skips horizontally, failing to throw enough sulfur upward. And a 60-degree strike into the ocean vaporizes seawater instead of rock, significantly reducing the aftermath. In these alternate versions of history, the global food chain remains intact. Large-bodied dinosaurs continue their dominance, and the ecological space remains closed to the animals that would eventually become us. Without that specific 60-degree strike into that specific patch of rock, the mammals remain a peripheral group of scavengers. In the actual timeline, the collapse was total. The largest animals on the planet starved as the atmosphere turned opaque. Early mammals survived because they possessed a very specific set of traits. Their small bodies required less energy. They could shelter underground from the surface fires and the cold, and they could subsist on seeds and insects while the world was dark. The lineage of those survivors leads directly to humans. We are the direct beneficiaries of a mass extinction. The near-total destruction of life on Earth 66 million years ago is the mathematical prerequisite mechanics of the Chicxulub impact, the relationship between mass, velocity, and planetary defense. This research for missions like NASA's Double Asteroid Redirection Test, or DART. In 2022, DART successfully collided with an asteroid moon to prove that humans can intentionally alter a space rock's angle. A random, unchosen angle ended the age of the dinosaurs and created the room for us to exist. We are now the first species capable of choosing that angle for ourselves. That was Chicxulub, a single trajectory and a patch of sulfur-rich rock that determined the cast of life on Earth. 4.5 billion years earlier, glancing angle. That strike gave us the moon, setting the stage for everything that followed. Tomorrow, the moon that almost wasn't. You're going to want to see this one. We have moved from being passive recipients of the universe's geometry to the species that can